Now, a bird flies at a uniform speed of 22 meters per second. If it wishes to fly to its nest, which is 250 meters due north of its present position, there is a wind blowing from the southeast. From being the keyword southeast, you got to change it around to northwest, because that means that the wind is actually blowing northwest. So northwest is diagonal up and left. Okay. Now, what you do is there's a tricky question here. Okay. Now, what you got to realise is velocity of bird. That means the velocity of the bird in wind. Okay. Velocity of the bird is what actually happens to the bird. If there's a person on the ground looking up at the bird, he sees the bird travelling to its nest. So the bird does indeed travel north. Okay, so what's the velocity up there? Just the velocity observed. Okay, and then minus velocity of the wind. Now guys, I'm going to rejig this formula to make velocity of bird equals velocity of bird and wind plus velocity of wind. Now, as stated in the last question, I break this up into magnitude and direction. Okay, and I break this up into magnitude and direction. What happens is I need 4 pieces of information to do the question. Okay, 4 out of the 6. Now, I'll also draw a diagram. The diagram says that the bird wants to go directly up from its current position to nest. Okay. Now, what velocity? What direction do you think that is? Is it phi b or phi bw? What actually happens? Phi b. What actually happens is the bird goes north. Okay. I've used phi b. I have to start off phi b and one of these at the same point. Which one will I start with? Sorry? I can start with VW. I know everything about VW, don't I? I know that VW is going a magnitude of 18. I know it's going north, west. I know the velocity do I know the velocity of the bird? I know that it can do 22 in air, and I know that the direction is north. How many pieces of information do I have out of the 6? 4. Exactly, all you need, 4. Okay, and look what happens now. What I'm going to do is I'm going to draw the velocity of the wind going to the left, and then I'm going to link that up with the velocity of the bird. So here's what the diagram looks like. This here's phi b. This is phi w, and this is phi bw. Okay? And what we're going to do is we're going to need this diagram down here. Okay, let's find out some angles. What can we say about this angle here? 45, because the velocity of the wind is going northwest, so that's 45. The direction is going 45 degrees. Now, what can we say about the velocity of the bird? We can't say anything. Velocity of bird and wind, 22. So we can put this here as a 22. And what about the velocity of the wind? 18. We can do a sine rule and calculate angle x. So sine x over 18 equals, anybody? Will equal 45 over 22. Now just reread the language for a second. The direction, not directions, okay? One answer, not 2. Now let me explain why I'm thinking that. Sine x equals, can anybody get 18 sine 45 over 22 for me? And sine inverse, just sine inverse that for me. What is it? 35. 35.35? Now, you also have to consider the second quadrant, lads. You also have to consider the second quadrant. And what would be the angle in the second quadrant? 180 minus this angle. And what would that be? 144.65. Well done, 144.65. Why can we rule that out? Because the 45 degrees rules it out. Because if you add on 45, you don't get 180. You should check that though, because sometimes it works out, and sometimes you have two answers instead of one. It should say in the question though, directions as opposed to direction. Okay, now we know this. Does 1 to the nearest degree? To the nearest degree, okay? So we know that this here is 35.35, yeah? Now what does that make the last angle? What does that make this angle here? 35.35 plus 45, take away from 180. Anybody gonna tell me? 90. Actually, we don't even need that, do we? Because it's an alternate angle, isn't it? So we can just say that the bird goes north 35 degrees east, because it's an alternate angle. Yeah, does everyone see the alternate angle? I'll just spell it out for people at home. Alternate angle 35 equals 35. Okay, moving on. What's the next part of the question? The time taken to reach the nest corrected 2 decimal places. What do we have to find out? We actually have to find out the velocity of the bird. And as it turned out, we needed that angle anyway, didn't we? So what did we say that angle was? 99.65. So we're going to do another sine rule. We're going to do phi b over sine 99.65. And what will that equal? Either one. We can do let's do 22 over sine 45. Cross multiply. Can somebody give me the answer for this, please? 22 sine 99.65 all over sine 45. What do we get? 30.67. Perfect. And time equals distance over speed. And finally that will give me 200 and how much? 250 divided by 30.67. And what do we get? 8.16, yeah? Seconds. Okay guys. At time 0, 2 particles P and Q are set in motion. At time equals 0, Q has a position vector of 20I plus 40J relative to P. So what we can do is we can P can go here, and then Q can go up here. Now actually I'm not doing the diagram justice at the moment. Why am I not doing it justice? Because opposite should be taller than adjacent. So I'm just going to come in and just make it a bit more accurate. There you go, bit more justice there, okay, with that sort of angle there. So that's the angle in between the two of them. And what we have here is 20 plus 20 and 40. And then we have Q here. Okay. Now, find the velocity of P relative to Q. Phi P is 3I plus 5J. Phi Q is 4I minus 3J. And then what we're going to do is we're going to take them away from each other. So we're going to get phi QP, velocity of P relative, velocity of Q relative to P. Now what does that mean? Which one is fixed in position then? Which one's fixed in position? P. P is not allowed to move now because it's the second letter, not the first letter. Velocity of P relative to Q. Okay, so let's put that in, and what do we get? We're going to get a 4I minus 3J And then we're going to get minus VP, which is minus 3I plus 5J. What do we get for that then, lads? I think we'll get I minus 8J. Now, having done that, find the shortest distance between P and Q to the nearest meter. Shortest distance, okay? So here's the deal. Okay? What I'm going to do is going to draw myself a slightly bigger diagram. P, Q, P is stuck. I'm going to find their initial position. How do I find their initial position? Pythagoras' theorem. What was in Pythagoras' theorem? 20 squared plus 40 squared? Good luck to doing that in your brain. Just do it in the calculator. 20 squared plus 40 squared. 2000 square root it. 20 root 5. Okay, so lads, this is 20 root 5. We can also get the angle. Tan inverse 2, isn't it? Tan inverse 40 over 20. What's tan inverse 40 over 20? Or tan inverse 2? 60.435. Let's just call it 435, okay, because we don't want to take too much off it. Okay, so we're finding out a lot of information right now. We're a lot better off. Now, what I'm going to do here is I'm going to find out the direction of this one. VPQ. VPQ is going across 1, or sorry, VQP is going across 1 and down 8. Very steep angle. Okay? So this is going to be 8 and that's going to be 1 and we call this Y. What is angle Y? Tan Y equals 8 over 1. What's tan inverse 8? 82.875 again. So we're just going to not. When you get 5 at the end, you're not going to round it off because it's just too big of a round off to do. It's like dead center, so you're not going to do that. Okay. Now, look what happens. This one here comes down at a really steep angle. What does this line represent here? This line here, what does it represent? VQP is the dotted line here. Okay? And this line here, VP, that's the distance between the two of them at the start. Now we have some angles, don't we? What's the first angle we know? We know this to be 63.435. And it says shortest distance. Now, do you know what the problem is with that? We actually don't know that that's 63.435 because it has to be perpendicular, like so. So that 63.435 information isn't going to apply here. What is going to apply is the angle, which is actually the distance, which is 20 root 5. What's also going to apply is this here. Actually, our 63.435 that we're talking about a second ago, it's about to come in handy. And why is it going to come in handy? Because it's an alternate angle. Yeah? So that there is going to be 63 point, what do we say, 435? Yeah? And it's going to be 63.435, and what angle is this here? See the Q? This angle here is going to be 90. So we're going to have to add on this part here, aren't we? So this part here is, actually we get it now, this part here is 82.875, and that means we can now find out what the middle angle is. So how do we find out the middle angle? Add the two of them together and take it away from 180. Okay, minus 180. And because we rounded off to 3 decimal places earlier, our answer here is very close to perfect. 2 decimal places, 33.69. Now, we're asked to find the closest distance. What's the closest distance? Here to here at 90 degrees. So what function are we going to use? So sine 33.69 equals, call it d over 20 root 5. d is going to equal 20 root 5 sine 33.69, and what do we get? Sorry, I didn't hear that.
25.
Or 24.8, is it?
Nearest meter.
It's the nearest meter, which gets me 25 meters. Now, it's also going to ask me for the time. Find the time when P and Q are close together, correct to 1 decimal place. This means that I have to find out how far did Q relative to P actually travel. How far did it actually travel before it got to the closest point? I'll need 2 things. The first thing is I'll need the speed of it. The speed is the hypotenuse of 1 and 8, root 65. It goes, the velocity of Q relative to P is root 65 meters per second. I now need to find its distance. How do I find its distance? Cos 33.69, we'll call it x here, equals x over 20 root 5. Can anybody in class tell me what 20 root 5 cos 33.69 is?
37.2.
Don't round it off for a minute. 37.2 what?
104.
104, right? We're going to divide that by root 65. Distance divided by speed. Or you could have just put the root 65 underneath the original equation if you wanted. And what does that come out to be?
4.6.
4.6 seconds. That's exactly what we're looking for. 4.6 seconds.